Welcome back to the Minecraft world generation tutorial. In this part, which is part 6, we're going to be covering generating the cave system and other things underground if we have time for that in this part. So I think a lot of people have been looking forward to this, and let's get straight into it. For this part, we are only going to be using one blueprint, and that is the A chunk, but we'll just need to make a very quick change in the game mode, just that it's set up so that we can do this testing a bit quicker. So what we're going to do is just, instead of this, we're just going to put 0 on all of these, so that we only have to generate one, so it will be a bit quicker. Because right now we're going to start to see the roadblocks of why my project and this whole tutorial is kind of not game ready, because there are limitations as far as for loops go, and I think some people in the comments have seen them and have asked about them. So the reason I haven't gotten around to answering those is because I'm going to be explaining that either in this part or the next few as to why you can't, for instance, put 11 and minus 11 here and you get crashes for infinite loops. So I'll get to that in a little bit, but for now, we're just going to cover this right here and make one chunk. So right now, if we compile and save, after having put these both to 0, we should just have our corner right here. So our chunk in 0, 0. Now in the last part, what we did is we changed how the chunk was generated, where we just disconnected our logic here. So let's just put that back for now, and we will move that to the side. We won't be using this anymore, so we can actually just go ahead and delete it completely. And now if we go back and play, we have our chunk generation. There we go. So the first thing we're going to do here, before we actually go into the chunk, we'll just get this out of the way now, is we need a means of noise for the caves. Currently, right now, we have a noise for our surface, but we don't have a noise for our caves, so that'll be different. So we need to go ahead and make that first. So we'll attach it along this way. We'll just copy this and this. So Control-C, Control-V. There we go. And we will be making a new variable, because we need to be able to get the information again. So promote, and this will be cave noise, we'll call it. Now we're going to be making 2, but we'll just start with this for now, and later we'll add the rest. So there we go, we have our cave noise. Now for the variables, we want to, last time actually I didn't do this, but we should do it as well. We should do it. So currently right now, if we run the project like this, it doesn't matter how many times we run it, this will always give us the same result. So, but we don't want that. What we want is we want it to be randomized. So to randomize it, we need to add, well, a random seed. So this is where the actual seed comes in and allows us to, if we input the same value, to get the same results. So to do that, we want to make a new variable for the seed, which we will just call random seed, and it will be of type integer. We'll be setting it right here, so hold Alt and let go, and attach it up. Now, to get a random number, just very simply, random int in range. Now, in our case, we'll just put range, but you could also just put random int, that's fine as well. And we're going to put 10,000. Obviously, you're free to put it higher, it doesn't really change much. Now, we just need to connect it here, so that way it applies to our different noises. So the same thing here as well. So now, if we go and play, we have a different result than last time. If we do it again, once again, a different result. And it will just keep on doing that, no matter how many times we keep playing, until we've done 10,000 iterations where we might just start getting the same stuff. And obviously, if we input a manual value instead, we will get the same result every time. So, with that out of the way, let's get into the actual noise that we came here to do. So for the noise for the caves, I ended up with 0, 1 on frequency, so like this. And I believe I left most of the rest the same. We keep this as Perlin. And the reason we do, it looks very similar to this, is because the fast noise wrapper also has the option to get noise 3D, which with this we'll be able to draw an actual cave instead of what we used here, which is 2D. So we'll delete that, and that'll do it for now. We'll go move back to the chunk for the moment. As I mentioned previously, Unreal has by default an issue, or it's not an issue, but more of a safeguard when it comes to loops, and more specifically, infinite loops. Now, there's a value in the project settings, so if you go to edit project settings here, and we look for loop, you actually have a maximum loop iteration count, and that's what some people are encountering when they're trying to make the world bigger. And the reason for that is pretty simple. This is the maximum value, which I believe is by default 1,000,000, if I'm not wrong. Yeah, so you have a maximum of 1,000,000 on a loop, but that's kind of hard-coded, and it can be that it's lower and it will crash anyway because you try and iterate too much. Now, in our case here, just to give a very brief example, if you currently, what we did in the past is we had 3 by 3 on a grid, so that means 7 on the X, 7 on the Y. So that would be the same as saying 49 times 16 times 16, and you'd be doing that in a single frame. Which is why if you try to increase the size of the map, you're doing the same thing, but you're exponentially increasing the amount of loops you have to go through. And in that case, that's why sometimes you'll get a crash. If we take the example of one of the comments that said 11 by 11, that would be like doing 23. So if we just get a literal integer here, and if we say we're talking about doing 23 times 23, which we are then multiplying by 16 times 16. So it's trying to do over 135,000 iterations of a loop in one single frame, and that's a bit too much, especially when it involves generating an instance or spawning anything. It tends to be difficult. Even, I believe, in the initial showcase where Unreal showed this scenario in their own videos, I believe even their PCs would crash at 10,000. So, or not their PC, but their engine would tell them an infinite loop at 10,000. So this is way above the mark of it crashing. So we have to work around this, because currently right now, the extra thing that we haven't even talked about here is this is 16 by 16, but then we also need to multiply it by something like 80 for the height. And then we get to, well, about a million. And that's too much. That'll 100% sure crash it if we do it in one tick. So the solution to this is we kind of have to work around it with either timers or the event tick or other things like that. And so that's kind of the main issue as far as the project goes. And it may not look that bad now because you can just say, well, you just load the map. But the thing is, to load a chunk, when you'll see in a bit, it takes about sometimes 2 seconds. And if you do that for however many chunks you have, you don't want to make the player wait for 10 minutes to be able to play the game. That's a bit too long. So I managed to get some workarounds where the load time is still pretty long, but it stays under like 30 seconds if the map isn't too big. But the problem comes later, and I'll get to that in the next parts. Let's approach that problem now, and we're going to try and generate this chunk without making it crash, because by default, if we just do 16 by 16 times 80 for the height, we still get 20,000. So it's likely it would crash anyway. So we're going to try and work around that with the event tick. So to start, we don't actually even need this anymore right here, because we're going to be doing this on the event tick. So we're just going to be moving it out of the way for now. We're going to get our event tick. One thing we can do to help the event tick, or to kind of fix it, is we're going to go into class defaults, or just click on the chunk up here, and we're going to be setting the event tick, the interval. If it's 0, it'll do every frame it has, but we're just going to fix it to, I believe it is 60 divided by, or 1 divided by 60, which will be about 0.17, or 0.017, sorry, which is just kind of saying that it will do 60 frames no matter what. That way we have a kind of benchmark. Now, we can make it lower. If your PC is a lot faster, you can definitely reduce this. But I just fixed it because most people will be playing at 60 frames. So if it doesn't work at 60 frames, what's the point? That means it's only limited. It will only work on your PC, for instance. So we limit it here. And now we can get into it. So the way we're going to do this is we are going to have a function here that, well, more like we're going to have a custom event, sorry. So we're going to make a custom event first. And this will be called CE for custom event load level. And this is going to take in an integer right here. This is going to be levels. And the reason it is levels is because we're going to make this so that when we call this function in event tick, so we can just grab it from here, event tick will say, or sorry, no, well, the point of this, and for some reason doesn't have the name, let's just refresh that. What we'll do is every tick we will try and load an amount of levels here. So by default we want it to be 1. Let's just do that here by clicking on it and saying default value. We want it to be by default 1, so that means every tick we load 1 level. But what we can do is we can actually check and tell it, well, hey, can we say that we're loading the whole world? In which case we can do it a bit quicker, because if it lags, that's okay, because the player isn't there. So with that in mind, what we'll do is we'll put a select here. And to know how we're going to do the select, how we're going to do this here, we're going to make a very quick macro. And that macro currently won't work because we haven't set the rest up in the game mode, but we're going to be doing that for this part. Is going to be called isLoading. And the whole point is we need to be able to find a way to know if we're loading the map. And the way to do that is going to be very simple. We're just going to not spawn in a player character until the map is loaded. So what we need to do then is we just want to say get player character. We're going to check if it is valid. And then we're simply going to say if it's not valid, not boolean, sorry, not valid. If it's not valid, then we are trying to spawn it. Then we don't have it visible. That means we're trying to load the levels so we can go a bit faster. So isLoading can now be closed, and I can also close these, don't need them. So for pick A, we just want to plug this in right here, like this. There we go. And so now we have our isLoading, and very simply, if it is loading, we're going to put something like, I put 9, but obviously you're free to change it. But 9 seemed to be the correct value after testing a bit. And 1, obviously, if we're not loading and the player is there, we just want to do 1 at a time. So we move that here. Now we need to do our loading. Now, loading itself will also have another function, because there are a lot of small variables, because we need to kind of do the same thing as we did in the ISM block that we did here. We're going to have to do something very similar to this whole spaghetti thing. So that's why we need an extra function for it. So the first thing we need to do is, because this is supposed to represent the amount of times we do this, we're going to do a for loop, but we want to have a break. And the reason we want to have a break is that if ever we go from, for instance, how we're going to do this is we're going to count down. So we're going to go from the top, so let's say 80, all the way down to 0. So we'll simply say if at any point this is 0, that our height is 0, then we break it. We don't want to do any more loops. So the levels go in here. The index becomes 1. And as I mentioned, we need to have a count to know how high we are. So we're going to need a variable, which is going to be the levels loaded, or level count. Sorry, not like that. Count. And so by default, this is going to be an integer, and we are going to set its default value to something like 80. Now, compile if it's not visible, otherwise it won't show. And what we'll do here is we will simply say decrement. And every time we go through this loop, we will decrement it. Now, with that in mind, we need to now use this to perform a function right here. And that function we're going to make, it's going to be called calculate instance map. There we go. And it's going to take in the integer of the level. So this is level in. Event. And so now we can call this right here, drag it in, plug the level count into it, plug the decrement after. And so now, as I mentioned, if this ever becomes -1, because we do want to do 0, 0 is bedrock. So if it's -1, we want to do a simple branch, plug the branch in here, and we will go back around to break. There we go. So just make some reroute nodes just so it's a bit more readable. A bit up. There we go. Now, if this is completed, so we need to know if our current level right here is once again equal to -1, because there's no way to tell whether a break was done, completed is called with a break. So we just have to say, well, it was broken, so we need to double check if it was, or if it was just finished normally without a problem. And so if it is, here we're going to actually spawn in all the instances, because here we're just going to calculate them and store them in a map for now. So let's get into the spaghetti. So the spaghetti is going to be this. It's going to be going through each level and trying to figure out what we need to spawn in, what it needs to look like, etc. So we're actually going to make another very quick function here, which is just going to be a means to know how big our chunks are, because right now we don't have that. So we're going to get that information here. So we're going to call this get chunk size. It'll be a pure function, and it's going to return an integer, which is going to be the chunk size. So just put this return value. There we go. So to get the chunk size, we need to get our asgm Minecraft, and we're going to get our chunk size. I don't know if we set that in here. So if not, we will just add it. So this is just so that across the different actors, we have the same chunk size no matter what happens. So this is just better for the long term if you want to make any changes. So create a variable, and this is in the GM Minecraft. Sorry, I quickly switched. Chunk size. And by default, we'll be setting this to 16. Our usual Minecraft chunk size. So we get that here, get chunk size, plug that in, and that's all we needed to do. So let us go back to our calculate. How this is going to work is we're going to do double for loop like we did in the previous one as well, but we're going to do this slightly differently. And so let's just go through it first in order, and then I'll maybe go back through to explain what everything does individually. So we want to start by getting our chunk size here, and we want to subtract 1 from it, because we're going to be doing loops, and loops usually start at -1 because of being at 0 initially. So this is actually going to be promoted to two variables. The first is going to be called end_x, and we're going to have the same thing after, which is going to be for y. So both of these can be attached to the same value. Just plug it in right here. Next, we're going to need another value, and this is going to be a vector array. And so this is going to be called spawn locations. It's going to be a vector right here, and right click to put it to an array. We're then going to say add. And so what we need to do is we're going to say, well, these are kind of the places where we're going to try and add a new instance. And so the first initial instance just needs to be at 0, 0, but it needs to take into account the height. So we're going to split this very quickly. And we're going to get our input here, which is called get level in, and it's going to be at the bottom right here. And we're just going to plug that into the Z. So what this will do is that the initial spawn we attempt to make will be 0 on the X, 0 on the Y, but at the right height on the Z. But that's just mainly to be saved. This is going to be the loop that we're running through. Then, this time, unlike before, we're going to use this, plug it into a while loop. So is not empty. And as long as it's not empty, we want to do a while. So attach this right here. And the reason we do it like this is just because it's not a safer way, but an easier way to process through the information of what we did before. So it's going to be very similar to what we did in the previous one. But unlike the previous one where we would go back and forth between saving different points, but last time it was very easy because we just had one possible error. Here we have to go through and check every different type of block. So right now we're just doing stone, but it also counts for empty space. It will count for any mineral you have as well. So that's why this needs to be a bit different. And with this, it will allow us to, whenever we do a new spawn, we can actually modify these so that it does a smaller loop every time, so that it's never redoing the whole system over again. So the first thing we need to do, just to make this more readable, is we're going to save this value right here. Or not yet, sorry, I forgot something. So the first thing we need to do actually is, because of how this works, we need to double check that we haven't already placed a block here, because assuming we run into an error later down the line because of how we're going to make this, maybe another block had the space to grow entirely over this new spot we wanted to make one. So we need to check that that isn't the case, so we'll be saving variables as we go. So for that, we want to make a new variable, or actually first what we'll do is we will get a copy of this. And obviously we're going to be working on 0 most of the time, there's no reason to touch anything else. And we're going to check whether it is contained, so array item contains item. And we're going to just duplicate our spawn location, and this will be called complete array. And we're going to have another one that's incomplete, we'll get to that in a second. So if complete array does not contain this, so not boolean, so like this, there we go. So if we do not contain it, we get to do the whole logic that's going to follow. But if it is contained, well, we just very simply want to remove the item. So remove index 0, because we just checked index 0 already has been used or already has been filled. So we just don't want to do this. So we'll just plug it in at the bottom here. Now, on the other hand, if it isn't, meaning it's not contained and we have the space to add it, then that means that we need to save that variable just to make it more readable. So we're going to promote this to a variable right here. I'm going to say L current spawn, we'll call it. So there we go. So plug this here. One thing we can do just to make this maybe more readable. So we'll just put all the kind of spawn stuff into a category we'll call spawn. So this is the location and the current. These, the end X will be put into a loop part, because there'll be a few more coming here, they're just not done yet. And the complete array will be part of a current category, we'll call it. And it'll be for anything that is active except for the spawn itself. So here we actually need a function, and we don't have this function yet, so we're going to make it after. For now, we're just going to set this up. So let's just go here, and we're going to need a new variable, and this one we actually have to do manually, which is going to be called spawn data asset. And so we're going to right click to put that back to a normal variable, and it's going to be DA base, and it's going to be a soft object reference. So we're going to plug this in right here, and then we're going to do a reroute here and a reroute here. We're going to select both of them, and we're going to collapse it to a function. And this is going to be called get data asset by location. There we go. So right click on this, not right click, sorry, just click on it and put it to pure. And we're going to be using this the second time, but for now we'll leave this empty. So actually, just to make things easy for later, when we test it, delete that, delete this, and we're just going to output a grass block. That's all. Next, what we need to do is with our current spawn, we're actually going to be able to save, or actually let's just first put this into spawn here. Sorry, the spawn data asset put into the spawn category. We're going to break this, our current spawn, and with it we can tell the loops where they start and where they end. So this is where we get to shorten kind of the whole looping process a bit. So this needs to be turned into an integer, obviously. So what we can actually do is in our loops at the bottom left here, we can duplicate the X and call it start. And we can then duplicate it again and call it Y start. So let's just do it like this, that way they're in the right order. And so for start X, we can alt click and put it here, and the same for the Y. And obviously this time it's not going to be equal, it's going to be X right here. And we can truncate it, it's fine, it shouldn't matter. And the same thing for the Y right here. With our start and our end setup, we can now get into making our loop. So we're going to start with a for loop with, or we're going to do 2 for loops with break. So get both of these, copy paste, going to be very close. This is going to be the Y. So we're going to get our start Y, we're going to get our end Y. There we go. And for the index, we're actually going to promote this to a variable as well, just so it's more readable. This is going to be current Y. And so this is obviously going to go into the current part right here. Plug it in. And we can just duplicate this. Actually, it'll be quicker than just rewriting it. So now we just want to right click for the start Y to put the start X. and the ny by end x. There we go. And this needs to be promoted to another variable, so we'll just duplicate it and say x instead. Right click and swap it to current x. Now let's get into our spaghetti. So, save that. So the first thing we need to do is we need to do a check, because we need to know whether our variable is different from... So before we would do here, if we take our example of our instance static mesh, is we checked whether the block was the error block. So that's not what we're going to do here. It's the same logic. We're going to check for an error, but this time the error is our data asset of our spawn different from a data asset of the current location that we're going to calculate. So here we're going to say get data asset by location, and we're going to convert this into whatever we need. So let's just move these closer so it doesn't take up too much space. And we're also going to have another one here, but that's just going to be, we'll do in a second. Let's just start with this. So if this condition is met, we need to check for our x. So we're going to get our current x right here. So let's just invert those. Current x, current y, and for z we're going to use our level in. So it's at the bottom here, I believe. Yep, there we go. And so we just plug these three into it, line them up, go. And so that will do our check. Now, so if this at any point is different, then we need to stop. We need to have our error here. On the other hand, what we also want to check is our complete array, do you contain the current item? Because even if the initial point isn't, if ever we encounter a point where it is, then we need to stop anyway. So here we'll split again, and we can just copy this, to be fair, and plug it straight in, because it will be the exact same thing, like this. There we go. And so if this happens, same thing, we stop. Now on the case where it is false, meaning it is valid, so on true it means we have a mistake, on false it means that there's nothing wrong and that we can keep going. If that is the case, we want to actually save these locations, because we want to say that, well, these locations are going to be occupied once we're done with this loop itself. The reason we don't use just complete here is because complete is used to check immediately. Now, the problem is if we go through this loop, let's say, and we go through the X and we arrive almost at the end, but there's something that's blocking, then that means that if we had a different row before, so a Y1 or 0 already done, then that means that something will be blocking it on the second row, and meaning it can't be a proper square, so we'd have to restart that line. So that would mean having to go back through complete array and remove everything. So instead of that, what we do is we make a temporary array that we will stack information in and then transfer it once it's valid. So we just need to make a new complete array, which we'll duplicate, and we'll just call temp array, because that's what it is. It is a temporary array that we will be adding later. So right here, we want to say add, and we can just do false. And what we'll add is just this information. It's the same thing. So we just split, plug it in. So that means that this information is valid, that we have confirmed that this block is available. And so next we just need to do the rest here on fail. So on fail, there's something we actually need to check for first, which we do not have, is we need to know how many times we have failed. Because if we failed once, that means that the item that failed is above the player. And that means that's fine. We're just going to make a difference if it fails on top. If it fails the first time, but it is on a second row, then we'll treat it as if it failed a second time. The whole point is so that we can kind of box in our cubes that we're making to tell where they need to stop. So let's just walk through this slowly and I'll explain it again. So first we need to actually get a new variable, a new integer, which we're going to be calling block count. So I just duplicated the X, that's fine. And this is going to go into spawning. So what this does right here is we're going to do a switch, and the switch only needs two things, and that is 0 and 1. It doesn't need the default because it's always only going to be 0 and 1. And what we want to do is we're going to have a branch here. And so if it fails on 0, that means it's by default. That means it's the first time that we've had something get in the way of our spawning. And so to check if that is a different problem, we need to know whether our start y and our current y are equal. If they are double equal, that means we're talking about the same y. That means we're on 0, so to speak. And if we're on 0, that means that the error is above, and that means, well, okay, we had a problem above. Let's just try doing the second loop, but with a different value. So we're going to say, well, maximum x is now equal to, let's say, 10. So we can try y1 up to 10. And if that's still fine, then we can just keep going. But if that's not the case, let's say on y1, so not y0, but y1, we had an issue, then that means that we cannot treat it the same way, because that means that the block went all the way to 15, because 0 to 16, so it went all the way from 0 to 15, and then on the next line, or the next row, sorry, it encountered an error saying that, oh, well, we could only go to 14. So in that case, we're completely blocked. We should have stopped at the initial y0 x15. So that's why it has to be treated differently. So if that happens, we can reroute here, and treat these two the same way. And so now, if this happens, so if it's blocked in a first case, so what we need to do here is we want to tell our spawn location, or our spawn locations here, that they have a new value, because we blocked, and that means that we need to make something new there. So instead of what we did before, we would just keep looping back around. Here we say, well, it's blocked, we just we stop this. So we just try and handle this differently. So for the locations, it's going to be the same as these. Just copy and paste them like this. There we go. Line these up a bit, just give it a bit more space. There we go. And we're then going to copy it and do the same thing at the bottom, but at the bottom we need to treat it a bit differently. So for the bottom here, we don't want to use current x, we want to use start x. And the reason for that is what we're doing is we're shifting it as far to the left as we can go. So that way, because of how the cube works, how this whole system works, is it starts at its initial value and then goes as far up as it can go and as far right as it can go. Meaning, if for instance we have an error where we stop at, let's say, 15 being the max, and we stop at, let's say, 13, then that means that in the previous one, the whole value under 13 is gone. Like, the whole values below 13 don't exist. So we need to stop that from happening by dragging the error or the problem block all the way down to the bottom or all the way down to the left. That way, it will always start as far left or as far down as it can, meaning it covers every area possible. So with that, with one error happening here, we need to actually increment this. So instead of incrementing, we'll just fix the values that we're sure that it's always right. So if it happens once, we set it to 1, so that we go through here the second time. And if it happens here, we want to put 2, so that we know that it's completely failed. Now here, we get to actually modify our x. And so here we get to say our new, end x right here, alt-click, is going to be different. And so we're going to get our current x and say -1 is the new value we're going to be using. But we do need to clamp it, because in some scenarios it can become -1, because if it stops at 0, it will go -1, but it can't do that. So we will just say start x is the minimum and end x is the maximum. Not on top of each other. End x is the maximum right here. And so with this in mind, with this here, it's still the same as before. We encountered an error, meaning we have to break the loop. But because of this, we've updated it now, so we'll be able to loop back around correctly without any issues. So make sure we go to the X here to the break. So this time we're not going back around and restarting, we are just ending it immediately, because we don't need it anymore. So now let's do the same thing for the second block right here. So if this happens, what we need to do is we need to actually grab our temporary array and we need to clear it. Because this means that the current array needs to be reset so we don't count this entire line of x. So we remove it, we don't take it into account. So what we need to do here is we need to actually take our current y and we need to decrement it. And the reason we're doing this is because right now after this, we are going to break the y itself. So we're going to stop this so it's not going to actually be called again. So this is the second loop we're going through. What we do here is we break it. So make sure you're putting these both into break and not into the restart. And so now we can finish this off. So now what we need to know is as long as our break or our block count, here is different from 2, we can actually add or append, more precisely, our temporary array here to our complete array. So let's just give it a bit of space right here. And so what we'll say is we will say complete array append our temporary array. Like this. There we go. And obviously, because we did this normally, because we did this, we then need to clear this array because it needs to restart after. It needs to start re-adding the information, so it needs to be cleared after this. And now the final step is we need to take this right here. So once we break out of this, and remember, this happens if we reach the end of the loop, or it also happens if we break out of it because we encountered a problem. So here, what we do is we want to do a branch, and the branch is going to be very, very simple in purpose. We want to get our data asset and check if it is valid. And the reason we check if it's valid is because if in a cave there is an empty space, we don't need to mention that we need to add a transform of an invalid data type. There's no point. So if it is true, we're going to be adding something. If it is false, we'll be ignoring. So now we actually need to add our map. And so this is going to be a variable, not a basic one here, but a proper variable, not a local one, sorry. This is going to be transform map. And so it's going to be of type transform. And then it's going to be a map with the data asset inside. So this is going to be DA base again. Plug this in with a soft reference. And now what we can do is we will say onTrue add. And we will plug it in right here. We're going to be making the transform in a second. So let's just move that here. And obviously the data asset will go right in there. So line this up. And so for location, very simply, we want to get our current spawn, plug that in right here. And for the rotation, we never want to touch it, we don't care. For the scale, we're going to make a vector again, just to make it more readable. And for the scale, we want to get our end x and our start x. We're going to say minus. And we're then going to add 1. So like this. And then the total gets plugged into the x right here. This, there we go. And so we're going to do the same thing with the y, but for the y, we're actually going to use current y instead of the end. So plug current y here and change it to start y. The +1 still remains. Plug this into the y. And z will be automatically, needs to be set to 1, otherwise you won't have any height, meaning it won't work. So with this, we now have our transform. We just need to now reroute this for a second, just so it's a bit readable. Go, plug this in. And what we want to do is we will say our spawn location, remove our index 0, because that's the one we just tried to place. And we then get to say that our end for our x, right, sorry, no, not that. Our end x, sorry, gets reset because it's the only one that changes. We never actually change our y. We just change our x, so we need to reset it back to being what it was right at the beginning all the way here. So get our chunk size again, -1. Plug that in right here. And we also get to say our block count back to 0. So let's just quickly go through it one last time, just so that everybody is clear on what everything does. We start off by setting our maximum x and our maximum y for the for loops. We then set our initial spawn location. So our array of spawn locations is how many items we're actually going to place, and to start it all off, we need to say, well, we have one, and that initial one is obviously 0, 0, because that is the initial size of the chunk. In our while loop, if we don't have anything, we don't do it, but we do, we just added one right here. So we're going to attempt to spawn that location. Now, if that location has already been used, obviously in the case of 0, 0, that's not the case, it's the first one. If that location has already been placed, well, we ignore it. That means that since we found that error, we've managed to take that place with another block. So we don't need to add two, otherwise it'd be overlapping. So in that case, if it is contained, we want to remove it. Now, on the other hand, if that block still hasn't been covered, then we want to make it a new variable just so we can save it temporarily. And so then with our new current spawn, so the location we're going to aim to spawn at, we need to know what we're trying to spawn there. And so with that information available, we now know what we're going to spawn, where we're going to spawn it, and now we just need to know how we're going to scale it. So with that in mind, we now know the start location. So the start location is going to be start x, start y. And so we plug all these in to our for loops. We save the current x and the current y, and we move on. Then we want to check if the data asset at the spawn is the same as the one used at the current location, or if the current location is already occupied in the complete array. Now, if either of these are true, that means that we have a problem. Now we need to block the information. We say, well, something is wrong here. We need to stop. Then we get our block count. So if we have no errors whatsoever yet, we haven't encountered any, and that our start location and current error are on the same y, in that case, we simply want to say that we have an error at this and this location, and that will be a new spawn location later, because we just want to make a new item there so we don't have an empty hole. Then we set our block count to 1 because we've already encountered an error now, so we want to save that. Now, in this event, we also need to tell our max x or our end x that now it has changed. It needs to be different because the max value has been set. We cannot no longer go that high. So we go ahead and bring that all the way back around to break it, so that we can then let the block count know, or let this information know, that we have finished an X line, and that information can be added to the complete array now, because we're sure that it's going to be saved. So then we go back through our loop, and we keep going until we encounter a new error, and until that happens, we keep adding new values to a temporary array, which will store the information that we might be able to cover. And now we get to our second error. Now, if there's a second error, or in the event that we have an error on the first go, but that is on a second Y, meaning we completed the first X line without any issues, then we need to do this as well. And then what we need to do is we need to save a new spawn location, but at start X instead of the current, because we need to slide it as far left or as far down as possible so that we cover all the area, and otherwise we would leave kind of holes behind and below. So with that in mind, we then need to say block count 2 because we have our second error here. So we need to make sure that the logic is aware of that. And we can clear our temporary array immediately. And the reason we can clear it immediately is because this error means that we have to remove this line, this X line, from our block, because otherwise we would have an issue. And that's the reason why right after here, we remove our Y, so that once we loop back around and complete our break here, we actually have subtracted it by 1, so that it doesn't have the actual current line taken into account. So once we're done, right here, we can complete it, and we check whether that we're trying to spawn something that is really there, meaning that it's not empty air. So with that, we check if it is true, meaning we actually have a valid reference. We want to add that transform. And that transform takes in the current spawn, takes in the start and the end and the start of the X, adds 1 to it because by default it is 0 and -1, so we make sure the scale is always 1 at least. And then our current Y and our start Y get subtracted as well to give us and +1, so that we get the scale on the Y. 1 for Z is always the case because we always do this level by level. After that, we then get to remove our spawn location 0 because we no longer need it. And we get to say we need to reset our X our index because by default, if we encounter a problem here, it's modified, but Y isn't, so we need to make sure that we reset this. We also reset block count back to 0, so that we don't have any more issues and we can restart the whole loop. So, I hope that makes it clear in your head for how this works. We can now close this, and for now we just have grass block, we won't do anything else. Now we need to actually go through this. We actually need to spawn our items. So, back in event graph, right here, if this is -1, that means we've finished. That means we've gone through the whole thing. Now what we do here, we get our map, and we say keys. And with our keys, we do a basic for each loop, and we're going to go through each one, and we're going to create our new instance. So, we want to do transform, we want to copy this and say find, like this, plug that in, and we're going to say make instance static mesh, plug our data asset into here, and then we can say add instance. Now the instance obviously here is going to be a reroute, and it's going to go right here, because this is the transform we're using for that specific static mesh instance. And then we can say right here, set actor tick enabled to false, because we no longer need the tick because we've just generated everything. So with that, we should now, if we play, have a chunk that actually generates. So now if we play, we can test this, and it does work. It just takes a bit of time. But we're having so right here we are getting what we want. It's just that these are all kind of going in height by 1, and that's not correct. The reason is very simple. It's because in here, we just plugged our spawn immediately here to here. But the thing is, this is in like block coordinates, which is not enough. We need to actually convert this to world space. We need to say times 100. So let's put float 100, plug this in. Okay, so with that little error out of the way, let's give it another try. It'll take a few seconds to load. Just pause the game so the character doesn't fall out of the world. And we have our 80 by 16 by 16 block. And if we look in wireframe mode, you'll see that because there's no problems, each layer is just one big 16 by 16 thing. So that's what we have right now. Let's get into making it actual caves. So one thing I just need to check very quickly is the assets we have. So we do have bedrock, but we don't have stone. That's pretty stupid. Okay, so update. I'm going to be giving an extra pack of assets because for some reason I forgot to put stone in here. So we're not going to be doing all the different minerals. I'm just going to show you how to do it for coal, and then you can obviously modify the different values and do the same trick for diamonds or whatever you want. I can't believe I forgot stone. Like that's a pretty obvious one. So let's just drag that in. And there we go. So just we need to double click it to open it up again, and just change the filter to nearest so we don't have the bug. Now, with this in mind, even if we have the textures, we still need to make our actual material or our actual data asset. So we're going to take our grass block, we're going to duplicate it, and we're going to make bedrock. There we go. Let's just double click to open it. We'll call it bedrock as well. And for the textures, we just want to change one of them. So we'll just reset this back to white. Look for our bedrock texture, and we will copy the whole thing. Paste, 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 and there we go for the last one. There we go. So just double check by looking very quickly that they've been changed correctly. So now if we have bedrock right here, we just need to do the same thing for stones. Let's just duplicate this and call it stone. So that's stone. So now we just want to open our stone one and look for stone and copy the whole thing once again, just same trick as before, paste them everywhere. There we go. So we can close that. So we're going to do this actually step by step, just so you kind of get a feel for how this works. So what we need to do first is we're going to open our get data asset by location. And we are going to break this. And we're going to say if our Z is inferior to 60. So that's how we're going to kind of do the below surface stuff. If it's below 60, then we will be using stone. Otherwise, we're going to use a grass block and say that that's for the surface. We'll handle that in the next part. The first thing we need to do is we need to get our input pin. And we need to convert this to world space. We're going to actually make a quick function here for that, just to make it easier. It's going to be called toWorld. And what it will do very simply is it will take in a vector. This is going to be in, and it's going to be pure, by the way. And we're then going to have our out. This could be made into a macro as well, but we'll just use a function here. This is going to be in blocks. So we're going to multiply this first by 100. Actually, no, sorry. First, we're going to add this to our chunk coordinates times the 16 times 16. So 16 here and 16 there. Doesn't matter about the Z, that's okay. And we're then going to add these together. And once these are added together, I don't know why that's not aligned correctly. There we go. We then multiply this by 100 on all axes. So float 100. Go, and we plug that in. So this will convert the world space. So actually what we should do here, which would be better, so we're actually going to split it. No, we'll actually turn this into an integer. And we will be using our chunk size instead, because that's what it's for. Let's just move this a bit closer. There we go. So now this will actually convert it no matter what chunk size we have, and it will convert it to here. Now, also worth noting, if you want to change your block size, let's say you want to use a different block than mine and you want it to be 50 by 50 instead of 100 by 100, then in that case, every time we have placed a 100, you can actually change that to 50. But you'll need to make some other tweaks as well, but if that's something that you want, it's mainly when we put 100, you should put 50 or whatever value you want. So we can remove this. I'm going to get this and say toWorld. And with our toWorld, we now have the world coordinates of our thing here. So what we're going to do is we're going to then break this as well. And if our Z is double equal to 0, meaning it is on what would be the bedrock, then we're going to return bedrock. So right here, we're just going to test that this is working first. We're going to do it step by step. And this will be stone. So now what we have is currently when we choose a data asset, if it is above 60 or equal to 60, we have grass block. If it is at 0, we have bedrock. If it is in between, we have stone. So let's give that a try and see if this worked. So play, pause it, and let's have a look. So we have bedrock, stone, and our grass blocks at the top. So it's working as intended. Now the next part is the caves. And now for the caves, we're going to make a quick function because it's a bit easier to handle, because we're going to be using it on the surface as well, because obviously the caves should sometimes come up to the surface. So what we're going to do is we're going to make a very quick function, which will be called getCaveNoise. And getCaveNoise, what it will do is it will return whether the current location should be a hole. So it's going to take in coordinates, so location. It is going to return value. It's going to return a boolean, which if true means that it is a cave. If not, it means that it's a block, so stone. Here, what we do is we're going to say this value is going to be in world space. So what we want to do is we will say from our GM Minecraft, we're going to get our cave noise, and we're going to say get noise 3D. And so we're going to have to get our location and break it and plug this in right here. Now, by itself, we're just getting the value here. So what we're going to do to check if the value, we're going to keep it, we're going to have a condition. And that condition is simply going to be if you are superior to a value that we're going to get right here. And so that's going to be, let's just say percentage, or value will do. And so just to make it a bit easier to read, we're just going to put value right here. Now, in our case, right here, we're going to use our 0.2, or we're going to use this node right here, sorry, so we just made as a pure, sorry. It's going to be 0.2 for the value. You usually want to keep it between -1 and 1. We're going to get our transform here, because we need to make sure it's in world space. And very simply, a branch. If it is true, then we put none. If it is false, we then put stone. Like this and like this. Now let's compile and save. And if this worked correctly, right now if we play, we should have our caves. Let's have a look. We do not. I feel like I forgot something. No, sorry. I think we just use this here. Yeah, sorry, we don't want to use the two weld here. Let's just try that again. Play, pause, eject, and now we have some nice caves. Now, obviously these caves are dependent on the seed, so if we close and replay, just pause it again, we're going to have different caves every time. And obviously these caves may look a bit weird here, but once you stack them up next to each other, because the whole seed continues, they'll look a bit more natural. So obviously here, it didn't work. There's nothing here because we told it only to do it on the stone. Same for the bedrock. The bedrock doesn't change at all. And with that, I believe... Oh no, we have one last thing to do. We still need to do our minerals. So we still need to add our coal. Now for the coal, we need another noise first. So we're going to go ahead and make that very quickly. So once again, copy this. Plug this in right here. Promote it to a variable, which we will be calling mineral noise. And for this, instead of what we did before, so just copy this, because we want to use the seed again, obviously. This time, we're not going to be using a Perlin noise. This time, we're going to be using a cellular noise. Now, cellular may not be the word most people know very well. This is actually Voronoi. That's another way of calling it, which may be more familiar. So that's what we're using here. We want the frequency to be 0.7 here. You want to lower this to 1. And I believe everything else can stay... No, we want to change the cellular return type to distance 2. And that will do it here. Now what this does is pretty much it will create like small kind of groups with the same value. So that way instead of having like how we have now where we have an entire line or area that flows kind of like with our caves, we're actually going to get something more like kind of groups, smaller groups. And obviously that can change with the frequency. The frequency will determine how big the groups are, you could say. And so with that, we then get to have our kind of mine or mineral veins. So that's what we're going to be adding. So now that we have our mineral noise, let's go back to our get asset by location. So for this one, what we want to do is, if this isn't cave noise, because if it's a hole, we don't want to actually go and add blocks because it would look strange. Sometimes they would be floating in the middle. So if this happens, we don't care. What we want to do is we want to handle it here. So we're going to put a branch again. And right here on output, if it's what we're going to look for is we're going to use the same thing we did here. So as GM Minecraft, we're going to get our mineral noise. We're going to say 3D noise again. And we're going to have to break our pin here to plug it in. Obviously, once again, we're using just the values. We don't need it to be world space. And if this is superior to 0.85, so right here, 0.85, then that means that we want to use coal. Yeah, so if that happens, we want to use our coal, which we don't have yet. So actually, let's just go and make that as well. So duplicate our stone, call it coal, open it up, rename that as well. And once again, we're going to change our appearance. So coal here. Copy, and as I mentioned before, sometimes it can look blurry, but normally we should have changed it. So it's just the appearance here. Paste, paste, paste. close this up. And so now we should have our output for coal. Sorry, no, wrong way around. If it's true, put coal. So one other thing you can add, for instance, if you want a hard limit on the heights, you could also say that, and this has to be inferior to, and the Z here has to be inferior to like 60. And for instance, if you want diamonds, then you'd have to say it has to be inferior to like 20. That means it's only below 20 you have actual diamonds that appear. So for now, let's just go and, so we have an error here. Okay, I think that's because we didn't compile. So make sure you compile in game mode first. There we go. So now if we play and pause again, if we go out, we have coal appearing. Sometimes it's just one block, sometimes it's actual proper mineral veins that appear, and it appears all the way up to the top. And obviously this can be changed by any other mineral. It could be iron, it could be anything you want. So with that, I think we are done. So this does it for our caves. I hope you enjoyed this part. It's a bit longer than the other ones, but I don't think there's much I could do about it unless I left you halfway through, but I'd rather go all the way to the end with our caves here. So I hope you enjoyed, and I will see you in the next part. In the next part, we're going to be covering the surface. We're going to be turning this back into what it was before with a bit more. So I will see you in the next part. Goodbye.